Okay, I think we will be slowly starting. We seem to have hit a plateau of people joining. So, somebody ran away. Worrying, it happened just as I started talking. In any case, hi everyone. My name is Aleksandra Jarmolińska. I'm a senior software engineer at Google, more specifically in Cloud Composer. So, one of our Google Cloud products working in Warsaw, Poland. Been here for a couple of years. And today I'd like to introduce you to the joys of Python, which I'm trying to explain to everyone on my team is absolutely the best language, but they are somewhat suspicious of that, to be honest. And before we jump into the code itself, I would suggest that you use this Colab notebook for that. This is basically an uh, well, a notebook in which you can actually run Python. This is interactive, so it's very nice for learning the language since it remembers everything you put in there, and also lets you easily retry just parts of your code. But of course, this is due to the number of people we have here, mostly going to be me talking. So of course there is no actual need, to do everything that I say. I will not be calling you to the whiteboard, so to speak. Okay, so maybe let's just jump right into it. Let me just switch. What am I sharing? Okay, can I get maybe some emote to verify that everybody sees the notebook? Okay, perfect. Thank you. And yeah, so maybe right. Uh, Thank you for reminding me of all the things that I didn't say. Yes, so of course this talk is part of the Google Summer Academy, and also we will be recording this session, and it will be published later on, in case you need to miss a part of it. Okay, so a bit of more of housekeeping rules. I would prefer if everybody had their mics off. I think that's correct right now. But I do invite you to enable your cameras so that I can see that I'm speaking to somebody. And yeah, if you have any questions, feel free to write them in chat. I'll try to answer them either during, if they are pertinent to what I'm doing right now, or at the end, if this is something more generic. And what else? Yeah, you can also raise your hand. This is this button next to, like, at the bottom row of your screen, where you can enable your camera, for example, again, and so on. And yeah, and then just ask the question if you prefer not to write it. Okay, so Python. Python is, I would say, a very nice programming language, since this is something that doesn't require any special compilations. You can, in a lot of systems, just write your code in a notepad and then just say Python, please run whatever whatever I wrote there, which makes it very easy and very popular for a lot of applications other than straight up, uh, you know, writing large scale code, writing applications, and so on. Like, for example, I'm currently a software engineer, but I used to be a bioinformatician, and Python was the first language that they introduced to us, because this was the easiest thing to allow us to work through quite a lot of data. So, of course, if you've ever had any experience with coding, you know that there is one specific thing that I need to put as basically the first thing that appears as part of learning any language, which is how to make our code print out the hello world statement. And in Python, as mentioned, a very simple language, this is very straightforward. I just need to call the print function. And side note, why are those Colab notebooks something I really recommend at the beginning? They do actually give you quite a lot of help already here. So I have a whole explanation of what it is that I'm going to be doing here. With the print function, well, it prints the values that I pass it to something. In this case, our standard output. So right here in the notebook. So let's just run this. Side note, as you can see, if I'm printing hello world, it already knows, like AI already suggests what's happening here. I am learning Python. Yes, definitely. So let me just run this. And of course, a print function is something that is very useful, in particular for any debugging. If you don't know what is happening in your code, print is always a good way to deal with it. And the second most useful thing when just starting to code is how to put in a comment. So basically, part of your code that is not going to be interpreted by the program, in this case by Python, but just something that will allow me later to remember why did I put something here, or what does it actually do. In this case, I'm proving that I'm learning Python. Okay, so next thing that I would like to show you is, of course, so in Python, well, basically everything is an object, and objects have some types. So a couple of most typical types that you can encounter in Python is, of course, a number, and this will also show us how to assign a variable. Here, once again, a quick digression, since this is both introduction to Python, but to programming in general as well. So in a lot of cases, when you're writing your code, you need to name something, mostly to know what it is, right? So, of course, seeing an object, very useful thing. But if I just have some random number here, in like 3 lines, I will not remember what this value was supposed to be, what does it represent, why am I saving it? Which is why it's definitely easier if I name it something that will allow me to remember what is happening. So in this case, of course, I decided to name it something totally useless, which is just a one letter variable, because I was too lazy, and that definitely happens a lot in code. But in this case, this is, well, here something happened, let's say. I would assume that something happened in 1657. No idea what. Maybe if somebody can check that and write us on chat, we can improve this naming. But yeah, now when I'm going to be writing more of my code, it will be easier to know why this specific value was important to me. And side note, obviously, it's very tempting to use single letter variables or some names that are understandable only at the moment that you write them. I would recommend not to do that, because let's imagine that you come back to your awesome code a year later. There is this pretty popular statement among software engineers, like, when I wrote it, only I and God knew what was written. Now only God knows. And that happens quite a lot. So comments and reasonably named variables are key to actually knowing what is happening. Of course, so I mentioned this is useful because later on I know what I'm going to be doing. So in this case, I know that behind this name, actually, this value is hidden. It's something that is nice for learning in Python, slightly less nice when you're writing the code, as a group, is that Python doesn't really care about the type of variables. So there are some strongly typed languages, for example, Java, where you create some variable, so some container for a value, and you need to say what type is it going to be. So in this case, this would be an integer, like a number. In Python, that doesn't really matter. Here, this year was a number, but a moment later, I can write that this is 16. Sorry, I changed the keyboard recently, and I'm still learning. 1657, and all of that is still going to work just as well. I'm hoping that I wrote it correctly, but since some AI suggested to me the rest of this text, I'm assuming that it's fine. And you can always check the type that your variable currently is by calling a built-in function type. So similarly as print prints something out, then type puts in the type as it's understood by Python. So in this case here, it's going to be str, which is a shortcut for string. Okay, so those are I wanted to say all the most typical and simplest, let's say variable types that we have. But of course, there is one more that's going to be important. Oh, not that important later on, which is a boolean. Boolean is basically a true/false value. So in Python, we put those in starting with a capital letter, and this is boolean value. Okay, so of course I can write some string, I can write some number, but the most important part of doing things is working on slightly more complex data structures at this point. So something that maybe contains other objects within it, other data types. And an example of that is something called in Python a list. In other languages, this is commonly known as an array, which, like, if we get really down to it, in a lot of cases is basically consecutive places in the memory of your program, of your computer, that are filled up with something, and they are looked at in some way as a group. So in Python, you can indicate a list by the square brackets. And one thing about Python, so I put in too many spaces. So generally in Python, white space, so spaces, new lines, indentations, and so on, are very important. Technically, the indentations around the equal sign, where, as you might have already noticed, we used this sign to assign something. Basically, sorry, I was supposed to mention it slightly earlier, but basically this equality sign, let's put in a comment, indicates that I'm assigning something. So let me put in an arrow with the correct direction to a name. So I'm assigning an empty list in this case to the name my list. Right, so the spaces around this assigning equality sign are not strictly necessary, but make your code a bit more readable. Okay, so I can create an empty list. Nice thing about lists in Python is that they are mutable. So you can always add something else to this. This is once again a difference between Python and some other languages where you need to define the size of your array. In Python, since this is implemented on a lower level, slightly differently, you can always just add one more thing to it. And in this case, you can call a function that is built in to our object. Like this function is not something that is generally floating around as a definition in our, let's say, code, in our, I would say it's floating around in Python in general. There are of course more specific things regarding some namespaces and things like that, but they are not necessary for us right now. So the append function is a method on our object, on more specifically the type of object that is list, and it allows us to add something to our function, to our list at the end of it, hence appending. And let's see how does it look like right now. Like this. If I put in something from the very beginning to my list, the new things that I'm adding are going to be appended at the end of it. Another useful data type in Python is something called a set, which is actually something called a hash set. Basically, a set, if you remember from mathematics, for example, is a container. Like I remember one of my university teachers telling us it's a container for various varieties of things. And that's not particularly a useful definition, but that's what it basically is. It's just like a big bucket to which you throw things with one important property, which is those things will not repeat. Like if you throw 3 identical things into your set, only one is going to be, let's say, kept. Because what it does below is just marks that, okay, something that looks like this is there. It doesn't take into account any counts. So yeah, let me add this set here. So a set can be created using the square bracket, sorry, not square, curly brackets, but also just as set keyword. And to this one, I'm not appending, since appending implies some order to things, like things were before and now I'm adding to the end. To the set, we're just throwing it in and, kind of shaking our bucket a little bit. Order is not important. So here, let me add it for now like that. Okay, so things that I've added are there, but if I add add the same thing multiple times, it's not going to show up here, because it only indicates that there is a 2. Doesn't really matter how many of them. And of course, as you can see here, set is once again something that is mutable because I'm adding things to it. Now, we have the hash set, but there is also a very popular data structure in various languages, which is called a hash map, which is basically a very nice structure for quickly checking if what is something that is attached to something else, let's say, or more specifically, you have in a hash map or in a dictionary in Python, you have a key that has some value attached to it. And here is a side note, if you're ever going to be trying to interview for Google, hash maps. Like there is a, well, I would like to say a joke among all the people that are interviewers at Google that we can solve 90% of our questions using a hash set or hash map. It's not a joke. Like, from the questions that I know, this is definitely something useful. So, dictionary in Python. Again, curly brackets. And here you can, you need to assign actually some value to a key. So if you see how it looks like here, we know that this specific key has a value attached. When you do this at the dict creation, you can put it in like that. Please note that the key value pairs are separated by a colon instead of like in the assignment here by the equality sign. So our key will have value 1, our key 2 is going to have value 2. Right, and an important thing about both, again, like both sets and dictionaries, since both of them actually use pretty much the same thing, like set, set just assigns to the value that you put in here, so it treats the value that you put in there as a key and just assigns a true to it, like it's here. So this is basically the same thing. So in both of those cases, again, like think of it as a big bucket, shaken and stirred quite a lot. Don't depend on an order in there. Don't depend on things repeating. Like here, I can assign once again a value to my key, and it's going to be only this new value. It will overwrite what was there previously, since it doesn't care. Like keys are a set. So if you change the values for them, whatever, we throw out the previous one. So all the data structures that those more complex, like list, set, and dictionary that I've shown to you, are mutable. Now, of course, that implies that there is something immutable, and this structure in Python is, for example, a tuple. Tuple is basically a list, except you cannot change it. So I can create it like that. Oh, sorry. Please note that contrary to the list, here we are using you're using the round brackets, and well, I cannot do anything like tuple append. There is no such function because, as mentioned, this is immutable. Now, why is it important? So I was calling both the dictionary and the set or hash map, because how is it implemented? Like, again, very low level, not strictly necessary day to day. It takes the key that you put there, calculates some sort of, so applies a hash function to it. So it's a function that basically extracts it to some value that matches whatever pattern it needs right now, and either marks this it's there for a set, or puts in specific place in memory assigned to this value whatever you wanted to be the dictionary value for that key. Now, that means that the thing that you put in as a key to your dictionary, or what you put into your set, cannot ever change, because if it were to change, you wouldn't be like the result of applying this hash function to it would also need to change, which means that you cannot use a list as a key for your dictionary, because somebody could come in and change this list. However, sometimes you would like the key of your dictionary to be something slightly more complex than just a number or just a string, and in such a case, you can use a tuple for that. Basically, this promises the dictionary that, okay, I'm not going to be actually changing this ordered collection of things. So that's the main difference between list and tuple, especially in application. Another very important thing to remember about coding is that programmers generally start counting at 0. Like, this is my 0th finger, which means that when you are going to be looking at part of a list, or like specific position in a list or specific position in a string, the first one is going to be the 0th element. And now, how do we actually extract something from, let's say, string? I can write some string here. Let it be Python. And now I can say that I want the 0th element of that by putting it in square brackets. I would say that, kind of by association to the list, like I want something from the list. And what do I want? I want the 0th element from it. So I put in square brackets and put in 0 here. Oh, yeah, I forgot to print it out. And this is going to be a P, which of course means first element is going to be the Y, and so on. And now a nice thing about Python is that it doesn't care. You can also always start looking at the elements from the end. So that means that I can put in that I want the last element. So in this case, it's not -0, because, I mean, come on, 0 and -0 is exactly the same. So this is -1, and it's going to be, in this case, the n, right? The last element, and so on and so forth. So -2 is going to be the O. Now, another thing that you could look at those minuses here is like a shorthand for length of my string minus something. Because one important implication in all of that is, since I'm starting counting at 0, that means that for my 6-letter word Python here, this is 0th, this is 1st, 2nd, 3rd, 4th, 5th. right? The largest index that I can have in my string here is 5. 5, which in this case, I could also write as 6, the length of my string, minus 1. And that's exactly this minus 1 that we have here. So this is, maybe let me write that in a couple of steps. So my 0th element is going to be string. Here, as you can see, I just extracted this to a variable, mostly so that I can use it twice. To also introduce another very nice function that we have in Python, which is len, which returns you the length of something. So a string or list, some ordered collection of stuff. Because of course, if you think about it, string is kind of like a list of letters, or more specifically in Python, I would think about it as a tuple of letters, because you cannot actually modify string. It's, you know, it's written, it's written in stone. But yeah, this is still an ordered collection of something else, of single characters in this case. So here, like, length of string minus 1 is the last element of that string. And speaking of, I was calling this an index, so note this. So of course you can always extract the index of some, if you have some element, you can find where it is somewhere else by referring to the index function. So if, let's say, I have some couple of colors and it's going to be, okay, perfect. No spoilers. I didn't want to have a 4 yet. Sorry, this AI is helpful, but in this case it's skipping a bit ahead. So I can find the index of green in my tuple of colors by requesting the index. Again, please note, this is built into my data structure tuple in this case, because of course not everything has indices in it. So this is a built-in, and yep, index of that is 1, since this is 0, 1, 2, right? This is the second element, so actually with index 1. Okay, so those were all our important types and data structures, but I mean, come on, you can always just write some number somewhere. This is not what programming is about. So let's do something a bit more interesting. So let's move on to control structures. Control structures, so places in your code where there is some divergent path that can be taken. This is also more commonly known as if statements. So let me for now write this as a comment. So if some condition is true, we will, oops, sorry. Okay. I can do something. Elif, which is shorthand for else if some other condition is true, I can do something else. And finally, else, none of those two conditions were actually fulfilled, I will do something. Maybe let's write it differently. So basically, that's the basic shape of this control structure, though the only thing that really needs to be there are those two first lines. Else if or else is definitely not obligatory. Now, as you can see already, I was mentioning earlier that white space is important, and you can see it especially here in this control structure. So while my if is, well, the pound sign or the hash is followed by a space always, again, for readability. So please disregard those two first columns. So you can see that my if keyword and all that follows it are without any indentation, but then the next line contains indentation. And this is very important in Python because in Python, we don't use curly brackets like we do, for example, in C++ or in Java to indicate that some part of code is to be taken together. In Python, we do that by changing indentation. So that means that if here I have multiple lines of code, they are all going to be taken together as things that need to happen only if this condition is considered true. So let's say, let me put something like that in here. So now, a quick question. Maybe somebody would like to answer this quickly on chat. What is going to be printed out? Come on, let somebody prove that you're listening. Okay, Gapstar?
Yeah, I just wanted to say that I don't see the chat. I'm not sure if it's a configuration issue or is it just me?
Can you try clicking on the, like, so do you see the row in which you can select like microphone, camera, and so on, right? On the
Yeah.
right-hand side,
Yeah.
you should have like, I think four icons. One of them are stacked blocks or various shapes, and the rightmost one, and then there should be the message sign, and it should be chat.
Yeah, no, usually it's there, but I don't see it. But I
Oh.
I just wanted to tell this to you so you know you're not alone. Like, we're hearing you.
Thank you very much, and I really appreciate that. But yeah, so I'm curious. Normally I would suggest, turn off Meet and turn it on back again, but please don't leave me. So I will just tell you what is happening on chat in this case.
Okay, I will try to reconnect, yeah, to see if it works.
Okay,
Thank you very much.
sure, thanks. And Walt? Sorry, Walt, you raised your hand. Raise your hand and run away. Okay, maybe they'll return. So I have answers, and this is 2, 3, 4. And yep, absolutely, this is the correct answer. Thank you very much. So yeah, so obviously 1 is not going to be printed out because false is definitely not true. Then we will print 2, and since again true is true, we print 3, and finally print 4, since this one is once again not actually subject to any. Okay, so Gapstar, I see that you just wanted to, brag a little bit about the size of your screen. I respect that, but yes, I'm happy that you managed to get your chat back. Okay, so then just to underline, of course, if it was written like that, then the answer would just be 3, 4, since 2 would also be, let's say, thrown out due to falling under the false condition. Okay, of course, this was a pretty simple example. Let me just prove that we were correct. So let's put in something slightly more complex. Mostly to prove, for one, that there are all those elifs that also work, and of course the fact that all of those conditions don't really need to be related in any significant way. So here, to go through this very quickly, right? I'm assigning this iable string to my var and 42 to answer, and checking. If 3 is less than 2, it's not, so I don't even need to read this part. If I in team, unfortunately, it's not there. So again, side note, I can check if something is in something else, which of course works for checking if some object is one of the objects within some larger data structure. So This can be a string, this can be a tuple, this can be a list, this can be a set or dictionary. Though please note that if it was a dictionary, we would only be looking if I is a key in that dictionary. And also, let's say that this, instead of the word team, here I would have a list of, I don't know, let's say TIM. Let's write the team really badly. So in this case, this would be correct. I is there. But if I were to put it like that, so it would be a nested list, and only within that nested list an I would be. This would once again be false, since we are only interested in very same level checking. Is this element immediately in the structure that we're looking at? Okay, so getting back, obviously I is not in team. So again, skipping this line totally. Now I'm checking if answer is 42. And here, please note that I used 2 equality signs, because 2 equality signs is checking if this is the same thing, or rather, is it equal to this? If I were to just put in equals, in Python, that would be an error, since I cannot assign like that within the conditional statement. In some other languages, like C, for example, this would be allowed, like putting in a condition like that within, condition like that with actual assignment, though it would be a very bad condition, since it would be basically always true, because it would assign and not actually check any value. But yeah, since we're talking about Python, if you're comparing 2 things, you are comparing with 2 equality signs. And once again, quick digression, if you wanted to check if it's not equal, then I would put in the exclamation mark equals, which is not in this case, but originally it was equals. And then if none of those conditions were true, I would go to else, but of course answer is actually 42. So the code decided for me what I'm eating today for breakfast. I have to say I'm very happy about that. Someone very smart wrote that code. Now, those were all actual conditions. So I was checking either equality or if something is something or in something. However, I can also treat, Python can treat basically anything as a Boolean value. I spoke about Booleans, so true, false earlier, but other objects can also be interpreted as either true or false. So let me add a bit more code here. So I can, for example, extract, let's say, a list to a Boolean. So in this case here, right here, my A is the Boolean value of a list, which has something, and B is a Boolean value of a list which is empty. So as you can see here, list which contains things is true, empty list is false. Here again, this list contains something, so it was once again the truth. And that's a general rule of thumb. So empty data structure is going to be false. Something which actually contains something is going to be true. So this is going to be true for sets, for lists, similarly for strings. Empty string, which I would denote as just, 2 quotation marks, is false. String which contains at least 1 letter is true. And somewhat similarly, it works for actual numbers. So here, 13, 0, minus something. And from those 3, only the 0, so the, let's call it empty number, is going to be interpreted as false. Of course, since we are talking about conditions and about Booleans, so if you've encountered this word before, you probably had some more experience of having logic courses at the university. So of course, in our coding logic, you can also use the keywords such as or, and end, and those are the logical interpretations of that. So if we have true or false, this is that's actually a very good point. So this changed slightly in that. So the Boolean that we get here, and actually, well, this is true, and this is false. Though, since I didn't actually give straight up true and false values, it returned to me the true from that, let's say, selection, and the false from that selection. So in this case, the empty dictionary, which was the false in my true and false statement, and the non-empty list, which was a true in that. But just to maybe make that slightly more readable, let me just put in actual true or false, and here true and false. So that, of course, matches the logical, and I mean that in terms of, branch of mathematics, interpretation of and as well as or. Okay, so we can select that our code will go somewhere or somewhere. This is starting to get a bit more intelligent. But now the main point of using computers is to have things happen for us multiple times so that we don't need to do it manually. So let's start with the most typical example. How do I print numbers from 1 to 10? From what we've already written, the simplest way to code that would be to do something like this, which is obviously a horrible way to print numbers 1 to 10, because let's be honest, it would be simpler to just write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? We can do this in a more, yes, Octavian, exactly, that's what I'm getting at. So now you guessed it pretty well, a for loop. So this is already a more concise way of writing things. So I can say that for I is the typical way, the typical variable name that we use in for loops, but of course it can be whatever else. I can call it Batman. So for Batman in this list, which will basically, I can just print whatever was assigned to this Batman. And how was it assigned? So what for loop does is it goes over all the elements in whatever I gave it, in this case a list, assigning it to the variable name that I specified just after the for keyword. So this for loop goes in here, checks, okay, now first I have 1, so I will assign it under the name Batman. Then I have 2, assign it under the name Batman, and so on and so forth. So just to write it out more explicitly, right, for variable name, maybe let's actually specify that it's just a variable name. It is not supposed to have any value beforehand. So for variable name in something through which I can iterate, list string, this variable is going to be assigned to the elements of that, and then I can do some stuff based on it. And once again, similarly as it was in the if statement, I'm using the indentation to indicate that this is the code that I want to do something with. So here I can put in more things. Let's say I would like to add 1 to Batman, and now nice Python shorthand for adding things. So plus equals is the same as this equals this plus 1. So it's basically just shorter to write. So I can do it like that. Right? And please note that even though I'm adding here to my Batman value, this is not sticky, so to speak. So after I printed out 1 and 2 in the first iteration, this is once again just reassigning to the next value from my iterable. So let me actually add 10 here to make this more visible. Like, this is once again on each loop it's going to reset to the value taken from my my iterable object. So yeah, so I can iterate over list, over set, over tuple, over dictionary, over keys in dictionary. Let me maybe underline that. And there is also another very nice method of looping in Python. So for is in general used to go over elements of something else. However, we might also want to do to just loop until some condition is correct. So we could write this as for element in elements. If something happened, break out of that loop. That's one way of doing this. But a shorter way of writing things like that is using a while loop. So once again, while loop that would actually print out numbers up to 10 goes like this. I start with some value, my number being 1, and until it's going to be equal to 10, or rather, while this is still less or equal to 10, I'm going to be printing out this number and increasing its value. So again, got the same thing. Now, while loop is very universal, but it also means it's slightly harder to use in that you always need to, for one, remember that you should probably, let's say, seed your condition beforehand. Like for is very well contained. It knows what it starts with and knows what it ends at. For a while loop, you might need to do some pre-work here. That's one thing. And for another, you definitely need to remember to actually do something that will at some point change this condition, because otherwise it's just going to loop around until you run out of patience, your computer runs out of memory if it was something big, basically, or you know, you give up and actually kill the program. So yes, definitely always remember to put in some stop condition for it to actually break at some point. And I was already mentioning breaking. So how to break out of this? Because here I already put in my condition that it's supposed to be less or equal than 10, but I could also just put in that it's supposed to loop around indefinitely. But once my number, so I print my number, and if the thing that I printed out was equal to 10, I can just break. That's a keyword that will break me out of the loop that I'm currently in. So if I do this in a while loop, it will break me out of this while. If I put it into a for loop, it will break me out of that for loop. So yeah, it just stopped execution in this point, even though the condition was still correct, since it was still true. Okay, so a bit more complex example. Break is, as mentioned, something that takes you out of the current loop, basically just teleports you to the place just after. Continue breaks you out of the current iteration, but not out of the whole loop. So in this case, continue just means that we get right back here, or rather here, to the moment where I is going to be assigned to the next element in our list, and pass just does nothing. It's in there usually to indicate that, well, possibly something is going to be happening at some point. I already created my whole control structure, but I haven't yet figured out what it's going to be. So, you know, this is just a placeholder to keep my indentation as it is. So here, let's just let it run. All right, so for number 1, oh, and one more thing that I introduced here, the percent sign between two different numbers is the modulo function. So it is I modulo 7. So since my first number was 1 modulo 7 is 1. 1 is a true. I decided to complicate it by adding the not here. So if this is not true, then this is false. So we go forward, and now I'm checking if I modulo 2 is equal to 0. Again, 1 modulo 2 is not equal to 0. So I'm going to my else and just doing pass, which is why nothing interesting happened here. For number 2, again, this doesn't happen since not 2 is not 2 is false, so we don't go in here. However, 2 modulo 2 is absolutely a 0, so I can print that it's divisible by 3. It's not, again, like 2 modulo 3, it's a 2, not 2 is false, so I don't go in here, so I can also add that it's not divisible by 3, and so on and so forth. Okay, I somehow thought that going through all those values is going to be slightly more interesting, but maybe let's not just go through all of those lines until we actually get all this input, because I would like to move on to my favorite part actually of coding that makes this all actually go, whole coding world go around, which is, let's get back to functions. Like we started this whole meeting with a function, the print function, which is the main thing we use for debugging basically everything. Now, this is a built-in function, like this is just available in the language from the get-go. We also encountered some functions, some methods that are built into a specific object. Now, of course, you can also create your own functions, and this is something that I highly recommend, because this is basically like, quick instruction for doing something that you define once, and then you can just relay that, okay, so now I would like to do things that are described on this other piece of paper, and you don't have to write them all the time. So that's one thing. So less writing, which is what we're basically trying to achieve when coding, but also this is something that can, again, like variables, where one of the reasons to use them is so that I don't have to remember what this specific string, number, whatever, what it is. I can just name it something, and then it's easier for me to understand what is happening. Functions also do a similar thing. Basically, I can extract some part of code to some helper function to know that those 5 lines are going to be doing this thing, and I don't need to read through them and try to understand them every time. I can just know that, okay, I named this, I don't know. It's like somebody tells you to clean up the garden, and then you can, of course, put in all the instructions one by one, that here you go, open the shed, you take the, I don't know, rack or whatever, and go do something with the leaves, obviously. But on the other hand, what you can do is add in a helper function, which is cut the grass. And you don't have to every time go through all the, like, of course the computer does it, but when you're trying to understand what is a part of making sure that the garden is okay, it's cutting the grass, and not going 10 steps to the left, opening the shed door, taking the mower, and so on, right? So functions definitely make everything much more legible. And how do you use them? Or rather, well, how do you use them when you are the person defining them? So here the keyword is def as a shorthand for define. So we define some function name, and again, like, doesn't matter what it is, it can be any name, though it needs to be a string, let's say. It cannot be a number, right? So it can be like b1, but it cannot just be 1, 2, 3. This is not a valid name. Okay, so we have some function name, and then this function can take no arguments. Well, argument is something that you pass to the function so that it knows what to do. So, for example, for my cutting the grass function, it would probably know quite a lot of things, since this is a function specific to my garden. And no, I don't have a garden, so let's pretend that I know how to mow grass. So in this case, well, the argument there would be to whether I would like to use a mower or, I don't know, go with the scissors. Let's say that it's a very small garden, right? So the argument would be use a mower. That would be a Boolean value, and either I take some useful thing, or yeah, just go and, I don't know, cut it with my own teeth. So I can pass in some arguments to my function. And then again, within the indentation are things that this function is supposed to be doing. And this still does nothing. Like right now, I only define the function. Now, if I want to actually use it somewhere, I call it as we were calling the print function earlier on, which is I put in the function name and possibly some arguments. So in the case of print, like this is the function name, and our hello world was the argument for that. Like, so just to show it once again. So just the fact that I defined the function does nothing, but then if I call it, things actually happen. It's about one thing. So indentation doesn't really matter how you do it, and this is actually a great debate among people that are writing in Python. So you could do it with a tabulator, like to do actual indentation as we usually call it, but you can just use a space. And the great debate is whether you should use spaces or tabs for doing Python indentation. Obviously, spaces is better. You can probably guess on which side of the debate I'm on. But yeah, so I even have a good argument for that. Tabulation can differ between different systems. Like on some systems, in some programs, it can be defined as 8 spaces. On another, it might be defined as 4 spaces. And your friend Steve might have defined it on his system as 2 spaces, which means that this is going to change quite dramatically depending on where your script is used. Spaces are defined as spaces everywhere, which means that this is the indentation that can actually be consistent between systems. So to answer the question that you asked there, you can just put in like 2 spaces or 1 space even. I would suggest 2, since we usually tend to do this in increments of 2, 4, or something like it. But 1 space is also still correct way as long as the indentation differs. So yeah, the function that I defined here, as you can see, it takes no arguments here. So when I'm calling it, I don't need to actually specify anything. But still, since I want to actually call this function, I need to remember to put in the round brackets here, because this is what denotes the word whatevs as calling a function, versus just this word, which in this case is just the object of the function, because in Python everything is an object, functions included. So let's write a slightly more interesting function, the one that actually contains some argument. So in this case, my auto superhero function actually needs to get some argument, and it's going to use it to print things out. So in this case, bad news, you just learned how Wonder Woman is really named. Of course, nothing's stopping me from use this in a totally nonsensical way. So, you know, that's the well, specific of Python. I told you that there is no strict typing. I can put in whatever here. So we learned something quite interesting about the 1, 2, 3 list. But yeah, the gain from the fact that I defined the function is now I can call it multiple times, and this will, I just don't need to care anymore about what this function actually does. I just know that I can use it in my journalist career to, learn more about superheroes. And of course, you can use this in a for loop as well to, again, do things multiple times. Okay, what else? Right, so those are functions in general. Yes, one more thing. is that I really appreciate this thing in functions. You can also, just in case you don't trust your user to remember to use it correctly, you can also create a default in your function. So in case some argument is not actually specified, you can put it in as a default. So if I call this out a superhero function while specifying some value, it's going to use that value. But if I don't put in anything here, it will use the default that I put here. So again, like just assigning this as a worst case scenario if the user didn't provide anything. So this still works. If this didn't have the this default, this would fail because it's missing, like the second call is missing the positional argument here that it's supposed to get. Okay, so this is about the general functions that we can define. A little bit more about the built-in functions of our various data structures that we learned about today. So in a lot of cases, I was mentioning that something works only on keys of your dictionary. So from that, we could guess that there is some way to just extract the keys from our dictionary. Though similarly, you can just extract the values by running the built-in function values. If you want to know what is actually in the dictionary, as in, actual pairs of things in a way that is going to be easily digestible by your program, you can also call the items functions. Anya, are you very sad about the world rolling us, or did something else happen? So I just saw some very sad emote going over the screen, and I'm worried that this is due to my treatment of the dictionary. Another nice thing is oh, yes, in which case I very much respect that playing with the types can make person cry. Yes, that happens. Unfortunately, often. But that just means that you're doing it right. So when we were doing lists, we were adding things to them, but you can also remove things from that. So to do that, since we're appending, then we can also, like, for list, usually you are adding something to the end, and of course that means that it's easiest to actually also remove things from the end. Basically, just detach the last wagon attached to our train. So you can do that using a very nicely named pop function, which takes extracts the last element from your list and also returns it. So here I can pop all the balloons from the end, like this was the last one appended, so pink, green, blue, and red. And of course, like the list is still there, so I can still append another thing to it. It's just going to be the only element because all the other things have been popped. For our lists, we can another couple of. I know that I'm going much faster right now, but I would like to still manage to do something interesting. So I'm trying to just introduce a couple of those built-ins before that. So for a list, what we can do is we can reverse it. We can sort it. So just to show you, like it was disordered. Here it was on reverse. It was still disordered, just the other way around. But I can also sort this. By default, we sort from the smallest value. For strings, you can use replace. Now, one interesting thing. So here, I was doing something to my list and then printing it later on. Here, I'm doing the same treatment to a string. So I have a string. I will do something to the string and print it. And please note that nothing changed. As you might remember from like an hour ago, strings are immutable. So when I called this replace function here, it didn't actually change my original string. It produced a new string. So if I actually want to get the result of this replacement, I need to get what this replace returns and assign it to something new. Oh, right. I was wondering why was it twice the same here? Because here I am actually printing immediately the result. So now I did actually get the better thing here. Okay. Now one last. Sorry, not last. Still a couple, but to make our programs slightly more interested in that they are interactive, there is also the input function, which waits for the response from the user. So here I've asked some prompt, some question, and my favorite food here is going to be bacon. And okay, let's say cheese, right? So this is already some sort of interaction with the user, right? I've asked the user for some answer twice, compared them. There are some results based on that, so I'm already using my if statement. Okay, and maybe one more thing here is, so when we were printing our numbers, we were actually putting all of them in here unless we were using while, in which we are generating them, but you can also make the code generate them for us. And for that, there is a great function called range, to which I can give two values, and it will generate for me all the integers, so like numbers that don't have any floating point before after them, starting from the first number up to, but not including, the last number here. So this was actually give us the I can put in here 1, 11, and now I have this values from 1 to 10 that I wanted from the very beginning. So until now we were talking about the code that we can write, with some small addition of the most typical functions generally available in Python. However, of course, in all the languages, people are writing code all the time, and in a lot of cases, they are producing some very useful libraries that contain already written functions. Like, you don't have to write your own sorting functions. Somebody wrote sort before you. And similar things are of course happening for many other useful things. One example of that being one of my favorite Python libraries, which is random. You can add a new library by using the import keyword, which will import the installed in your system like random. If you have Python, you definitely have random. It's just not available in your code until you actually import it. So here I can use functions that are specifically in that module, in that other library, so they are also only available through it. I already used the word namespace before, basically to not throw in all the possible functions, in which case we would run out of useful and reasonable names for things. They are scoped to only be used from a specific module. So here I know that in the random library there is a randint function, which gives me a random int from between the first and the second and the second value here. This here is a second argument to print. Basically, I just want all of that to happen in one line because we're scrolling quite a lot here. So here I would like random randint to give me 30 values from between those two values. And yep, that is what is happening here. So I have some 3s, some 7s. I have surprisingly only 2 4s, but of course that unfortunately happens in probability. Of course, this is randomization for, I don't know, playing cards with the computer. This is definitely not enough if you need randomization for like security or something like this. This is called pseudo-random numbers because they are only kind of sort of random. Okay, so with this, I can start using, with all the things that we've heard until now, I can start doing some slightly more interesting things. So here I have a function that will ask the user about what type of dice they of moves on a die actually do you need, and it will generate for them the result overall of such a die. So let's say I'm playing Dungeons and Dragons, I want 20, and unfortunately I rolled a 7, so I'm pretty sure that I did not hit. But I can do this a couple more times. So let's try it here. Okay, let's try it once again. Oh, 17. Now I definitely hit, so I'm satisfied with that, and I can move on forward. Random also contains a couple of other really interesting functions, such as, for example, shuffle, like here, which, as you might guess, shuffles the things that I gave it. So here it's actually an alphabet written in a reasonable way. And here I have some random order assigned to them. So with all of that, we can actually, since we're shuffling things, we can actually start doing more interesting things. So let's play some cards. And now I will skip a little bit of the code here because I was talking for quite a long time and I would like to show you something more interesting. So let's go through some code that I prepared earlier for playing a very simplified round of blackjack. So first off, well, there was a reason for why I gave you shuffling. I can create a deck of cards. So my deck of cards contains values from 2 to 10, and then well, all the figures actually are treated as 10. Well, the ace might also be an 11, but as I told you, this is going to be a very simplified blackjack. And of course, here I'm not allowing any counting of cards and so on. So this will only contain the actual numerical values of my cards, and I totally disregard the colors. But this actually gives me some deck of cards, or at least some values from a deck of cards. Let's just verify that. So let's print this. Let's create deck. Okay, so this is somewhat shuffled deck of cards. So now, how do we actually play blackjack? And here I will have quite a lot of helper functions, since I would like this to go as to basically create first some structure and only then fill out things that I need. So this hopefully actually gives us an example of how you would play blackjack. So what? First I need to have a shuffled deck of cards, right? Then each of my players will draw a card, and as you can see here, maybe actually, because I also created a player class, so maybe I will also put it on the screen right now. Okay, so until now, we were using only some built-in types, like we had this integer, we had string, we had a list, but of course, nothing's stopping me from creating my own type of object, and I can do that by creating a class. So here I created a class player, and a couple of things that a newly created class should have. So most probably it will have this very non-intuitively named init with all those additional, like this here is a double underscore. That's a typical keyword. This init function is something that is called when the new object is created. So here I'm just initializing a player that did nothing yet. So they will have some name. This is one of the arguments. So when I'm going to be creating a new player, I will need to specify a name. For now, they don't have any cards, so the sum of their whole hand is 0, and they are still playing. I've decided to add this parameter here, basically for me to easily check if they folded yet or not. So then, if they are in game, this is called draw if required. And again, like this is maybe not the most smooth name of the function, but it is actually a pretty I would argue readable one. So if required, possibly I'm not required because I'm not sorry, lost my cursor. Lost because ouch. Can you can still see my screen, right? Huh. That's interesting because my Chrome just decided to disappear. Okay, this is slightly problematic. So I will try to recover that. And yes, in the meantime, let me just continue talking about what we have on the screen. So I have this draw if required, because sometimes I am not actually required to do something when I'm not in the game. And this is draw if required from, to indicate that I already need something to draw from. Like this points to the fact that I also need to give some argument to my function. And now we lost it. Of course. Now that's a nice thing about automatic upgrades. They will always happen when you want it the most. So, yes, I'm almost there. You have some questions in the meantime. Please do. Okay, this is me joining here, and research note. Thank you, you. Sorry, I'm not set on how am I supposed to read the umlaut in your name, but thank you. I appreciate that. Okay. I need to, of course, put my password in multiple places. You need to always be safe. It's going to be so comfortable when you're trying to approve the fact that you're accessing something on at least 2 different devices and everybody is looking at your hands. Okay, so this is the thing that I was writing in. Okay. And so close, so close. Okay, so now I think I will be able to share it once again. We're back in business. Okay, perfect. So, yes. So where were we? Okay, so I was somewhere here, and my draw if required function required a deck. Okay. So what it's going to do if I'm still playing? This like I somewhere need to check if the player is still playing. I prefer to check it in as many places as possible. So here also, if I already folded, I don't want to take any more cards. And So if I'm taking a card, I'm basically just popping a card from this, and since I'm just keeping my cards as its numerical value, I can just add it to my current sum. And then this lost function is a pretty simple one. It just checks whether I went overboard. So in this case, well, this is like implicit folding, so I will not be doing anything else here. Also, my player implements the ask if wants to continue, which is basically somewhere where I can put this whole interaction. So if player is not playing anymore, obviously I don't need to ask them. Otherwise, I'm prompting my player by name if they want to continue playing or not. And depending on their answer, yes, if they are very sad and decide to fold, I just mark them as not in game anymore. And for easier checking of results, I'm also added this here. So to be fair, this doesn't really need to be in my player function. This probably would be slightly cleaner to be checked elsewhere. But yeah, when I was writing this originally, for some reason, it was easier for me to just have one player to check the situation in the game. So here, with such defined, with the player defined like that, I can implement my game. So here, starting with the deck of cards, each player will draw from this deck of cards 2 cards, right? That's what we're starting with. And now, while both players are in the game, and I'm pretty sure that this additional checking if none of them lost is not strictly necessary, but just in case one of the players is cheating, I'm also verifying that they have not gone overboard yet. Here, since we want this game to be readable for us, obviously if this were actual blackjack, all of that would be hidden, except for like everybody just knows their own cards. But here we're debugging this by printing what's the current situation. And again, like we ask one player if they want a card or not. The second player same, and if they actually want to, then both of them get a new card. And this is happening. Here we have this while loop until we have somebody that actually still wants to draw a card, so as they are still in game. Once they are not, we can print out the final standing and decide who wins here. So let me actually run my code here. So nothing happens, of course, because I was just defining. Here I defined a class, here I defined a function. But now I can actually play blackjack with 2 players. So yeah, here I'm creating my players by calling the name of the class. I create an object of type player with just name player 1, player 2. Name had to be specified as a reminder, since my initialization of my object does require something. So let's play it here. Okay, so we have 15 and 4. Player 1 is a brave soul. They don't fold. Player 2 obviously has quite a long way to go, so they don't. And unfortunately, well, player 1, that was a brave but stupid decision to actually draw a card here, apparently. But let's try this again. So 19, yes, definitely player 1 folds. Player 2 has 12, so let's play a bit more. And well, player 2 has now 21, so they can fold with with enthusiasm, even because they've won that, right? So this is already some game that we can play here. And of course, nothing's stopping us from creating another type of player, because as long as our player has those functions implemented, basically those 3, since lost is, oh no, oh, I also reference lost here. So my player just needs to have all those functions implemented. So I can create another type of player. This one I'll just show you here. So player with strategy, this is going to be a type of player. So here, while my original player class didn't have anything like this, when I'm creating a child class, I can say that player with strategy is basically player, except some differences. And the difference here is that I changed my initialization function to also get some strategy. So strategy is going to be a function. I named this here with this underscore FNC to underline that I want this to be a function, because remember, functions are also objects. I can pass them around. So here, in this ask if wants to continue, instead of actually asking the outside player, I'm going to use some sort of strategy function to decide if I want to stay in the game or not. So, for example, my strategy here could be just random, right? Of course, in 21, I want to return false as a result to my is in game. However, otherwise, it's just going to be a random choice, either a false or a true. Another function that I could create is a careful strategy. So the careful strategy would be if you are below 17, and still it's not very careful, but reasonably careful. If we're below 17, then I want to continue playing, otherwise it's a false. So now I can just create a game in which I don't even have to participate, because I can just create two players, one with this careful strategy, one with this random strategy, and ask them to play. So here, well, the random one, the random one actually won by having no idea what they are doing, but the careful one just drew a very bad card. Here, random strategy was the worst one. So here's already something playing. Now, one last thing, and I know that we're slightly over time. I'm hoping nobody's going to throw us away. Give me 5 more minutes, because I just wanted to show you one more thing. So here, as you can see here, in a lot of cases, the code was being slightly auto-generated for me, because of course we are putting AI in more and more things. So actually, you can not only like use AI to help you write code, and since this is the summer of AI, let's be honest, you can also, since we already have our blackjack implemented, you can ask Gemini, of course, Google, to play a game with you. So it's actually pretty simple to import Gemini into our game. So this is just a code that I stole from some CodeLab code, like CodeLab that you get by default when you create a notebook in this research collab. Something that this we don't need. Something that just allows you to. Yes, so I'm not yet sure how. Hopefully, we have Thi here who will show us, but I will do what I can to get the notebook, the cleaner notebook, not the one which actually has more comments, to you after the session. Yes, thank you for that question. So, yeah, I can actually import Gemini in here. One thing is that I need to have this Google API key, and if you do this, yes, I'm giving the access. If you do this through the code lab that's dedicated to that, it actually teaches you how to put in this secret, where do you get a key, and so on, and how you put it into our secrets here. So you will need that because obviously, this is some external system. It requires some quotas and so on. So it needs to know that you are the person. You are the person calling it. But now I can actually create a Gemini player. So this one is actually going to have a slightly different init function in that it will. I didn't end something here. it will actually create some communication with my model, and I will ask it to play the blackjack. I see a question. I will open it in a moment. Just want to finish writing my code. Oh, sorry, that I still need a couple of things. So yes. So at the initialization, I'm calling Gemini to actually initialize a conversation with it. Now, this draw if required. This is basically the same thing that I had previously, but this time I'm not importing, like to do this slightly differently. I'm not actually starting from my player class. This is a whole new player, but yeah, I still need to implement all my functions. So here, like won against is the same, lost is the same, draw if required is the same. So I actually should have just used player as my base. But here, the interesting thing is happening in this ask if wants to continue, because here I'm going to send a prompt to Gemini with their current hand value, and just ask them to decide if they want another card. Here, side note, when you're talking with all those AI models, one thing is that it's always more fun if you ask them to pretend to be someone. So, if you enforce some formatting. My favorite part, I asked Gemini to explain electrophoresis as they were a pirate, and it actually worked. Like, it was understandable, but there was some booty to be got, and the boss man did something. I really recommend it. It was fun. But another thing is that obviously, when you're doing anything that requires input from somebody else, here Gemini is somebody else, it's always better to tell them what you exactly want them to put in, like yes or no, and don't accept anything else. And Gemini actually usually listens to that. So this is like, the perfect I wanted to say volunteer for participating in your games. So yes, I just have it as yes or no, because this way I can easily just look if they want to play or not. Like, as mentioned, this is same thing as was previously there. So now I can actually run this so that my class is defined. And now let me finish big by actually playing with Gemini. Yes, they are ready. Oh no! And I would like to say that I wanted to actually win, but considering that I have 19 and Gemini has 20, I somehow feel like it's not going to go my way. But yes, I will. Ouch! I will fold, because obviously nothing good will come out from that, and unfortunately, Gemini decided that they don't want another card. Okay, let me try that again. Like, this is so close to finishing. I don't fold. And what now? I have 12, and Gemini, I think it has folded. And it once again won. Okay, so I think this is a moment where I just give up. Apparently, artificial intelligence is better in this game than me, and I even know what's the situation. So I think that this is a good moment to actually finish playing. So, Haynes, have Jupyter notebooks any advantages, disadvantages compared to the type of notebook you use here? I don't believe so. So, to be honest, I always assumed that this is a Jupyter notebook, except just implemented on Google Cloud. So, no, like, I'm using this one because it's easy for me, and I have good access to it. And there are quite a lot of code labs, but I've previously also used Jupyter notebooks. My wife uses it at her work, and she's very happy. So, yeah, that doesn't really matter. The only difference might be the ease of installing some additional things. Like here, I didn't have to install anything to like use this generative AI, but I think for Jupyter notebooks it's also pretty easy to install. So yeah, doesn't really matter, but I do recommend notebooks. Okay, folks, so we are out of time. Somebody is going to come here and throw me out any minute. So yes, so Mirko, to get back to what I said earlier, I'll try to figure out how to send the notebook that I've produced to you. I think Thea, or 30th Trainer, as you're named here. Are you still with us or not? So will it be possible to send the notebook later on to the participants?
Sorry, I had to put in my headphones.
Sure.
You can send it to all the registrants. We don't track only the participants, but if it's fine for you, we can send
Yeah,
it.
sure. Absolutely. So yes. So before all of you run away, spend 15 more seconds with me, because I also need to
Yes, I will
ask
take
you to fill out this
It's fine. I have put the link in the chat for
the
everyone.
feedback.
Yeah.
Yes, please fill out the feedback. Somebody is going to ask me about that, and I've lost the place where I actually have it. So close. I'm so close to actually sharing it. Sure? Yes. Slideshow. Yes. Okay.
Perfect.
So please leave your feedback. And yeah, I'm not sure about you, but I had quite a lot of fun. Thank you very much for participating. Once again, a big heartfelt thank you to all the people that had their cameras on. Mirko, in some places, you were smiling when I said something that I thought was funny, and I appreciate it so much. Okay, Walt, you wanted to say something? I think Walt once again raised the hand and then ran away. So in the meantime, Daniel, I hope that you understood at least something. But as mentioned, like, I have this notebook prepared. It has a bit more comments, so I'm hoping that with that you will be able to go through it once again and understand more. And as mentioned, like, the recording from this is going to be available as well. So yeah, once again, thank you very much, everyone, for joining. Please leave feedback, and we'll get the materials to you as soon as possible.